So you had one great talk, now you'll have a decent talk, let's say. And my name is Emil Alegroth. I'm a postdoc here at BTH. I did my PhD studies up in Chalmers University, and my PhD studies was on automated UI-based testing, and this is what I'm going to talk about today. And I'm going to start by basically asking you this question: do you automate? And at the end of the presentation, I'll ask you this question again, and I want you to answer, I do, right? With a really odd spell, but I'll get back to this. But first, some basic misconceptions about GUI testing in general. So we differentiate it from GUI testing, where we test the visual appearance of the application, what it looks like and how it feels and so on. And we differentiate this from GUI-based testing, which is testing through the graphical user interface, but then focused on the behavior of the system, right? So we're using the GUI as an interface. So the difference here, if we combine them, is that for verification, making sure that the system works at all, smoke testing, system testing, then we can use any of the two. But for validation, we need to take both into consideration, both the GUI testing and the GUI-based testing. Okay? Another way of looking at this is that if we take our system and we split it into layers, then on the very top of the system we have the pictorial GUI, what is shown to you on the screen, right? The images, the bitmaps. So for instance, a submit button or something, right? If we just start to dig down a little bit into the system, we realize that this button is probably defined by some Java code or some HTML code or something like that, right? So it could be, in this case, create a new J button, or the alternative there being an HTML string, right? That creates a button for a web page. But underneath this, even further down, we have some control code for this button, right? Some action listeners or something like that. And when this code is triggered, it's probably calling some other code of some sort, right? So we're digging down into the system, and basically what we call this is like a stack trace, right? From the GUI down. So we click on one button and something happens and code is activated, stimulated, and voila, fantastic result, right? But when it comes then to these concepts of verification and validation, then for a GUI-based system, we can split it like this. To do verification, we can do a lot of different testing on different levels of abstraction, unit testing, integration testing, and so on. But to validate the system, we need to put it into the hands of our users, right? Making sure that the GUI and everything underneath works properly, okay? So in order to do validation of a GUI-based system, you need to do it on the actual graphical user interface level. That's the takeaway from this slide. Do you agree?
Yes.
Sort of? Very good. So what's the difference then, and why should we care about these different layers? Well, one reason is because if we start talking about continuous ways of working, continuous integration, deployment, etc., the purpose there, if we just go from the V model, is to automate everything on the right side here, right? Automate the unit testing, automate the integration testing, and so on. And if we talk about different types of continuous ways of working, then for continuous integration, it is generally accepted that it's okay to just automate your unit testing and integration testing, because you're integrating things and sending it along to your next development team, inside the team, the next team, etc., right? But for continuous delivery, the next step along the ladder, you also have to take your system testing into account, okay? But you're still not sending this out to your customers, but you're still doing a lot of automation. However, for the grande finale, the continuous deployment, you also have to start automating your acceptance testing. And how do you do this? Well, problem, the GUI, the actual GUI. How do we automate this acceptance regression testing and take into the GUI into account, right? Either we put it into the hands of our customers, but sometimes that's not possible, right? So how do we do it in-house? Well, one reason is, so there is some need for bitmap GUI-based testing, right? There's some need for it in this context. And the problem is that there is a lot of automated GUI-based testing tools, but a lot of them do not take the actual GUI into account. In order to do so, you need something that can see what's on the screen. So you need some type of image recognition capability, something that can sort of see the same things as your customers. And if you do not have the image recognition, so you can't test a pictorial GUI, then you get problems like you cannot emulate the user properly because you're not using the same interfaces. You cannot perform regression acceptance testing, and you don't really solve these needs then with these tools for continuous deployment. So let me give you an example. Who here has heard about the tool Selenium? Some people have heard about the tool. So it's a very common tool in practice for automated GUI testing or GUI-based testing of web applications. And here's a small example that I'll show you. A lot of code, but I'll run you through it. So this little application is a real HTML site web page that I created. Don't judge me for the design, it was more for educational purposes, okay? So, but basically it's just input some text, you have a submit button and a console. Then for this we have a Selenium script that could look something like this, and in this case written in Java. And all we have to care about here is this line. Well, it's actually not tests, because it's getting the background color of the submit button and then just printing the background color, okay? But you can think of it as a test, because the data we get from this getting the background color would help us to check that it looks properly on the screen, right? Because in theory, if we get the background color here, it's blue, and we verify that, then we've seen that, okay, what is shown on the screen matches what is in the HTML code, and we can then assume that what's shown on the screen is correct. That's the premise, okay? The only problem here is, and this is an actual case, this is the output, and what it says down there, PG color RGB 018-12801, that actually says that the output there says that the background color of the submit button has 0 red color in it, 128 green color, 0 blue, and then the alpha channel, which is the gradient, right? And this is an actual case, and I haven't made it up. It's the actual output. So what's going on here? The tool says the button is green, but in reality it's blue. So what has happened here is something as simple as me putting a bitmap image on top of the button. But if you look at what the default state is, if the link to the image is broken, it's green. So the test case here would have said that everything looks good, it's green and nice, and but in fact the button was blue. So you need then a human to step in and take a look, right? So some problems here. So what else could go wrong? Yeah, so let's say we had this instance instead. This is something that I've actually taken from, as an example, from Spotify, where they once released Spotify with, you know, the little play backward button and stuff. They had exactly this problem, and they were testing on this level of abstraction where they're sort of analyzing the code and what it looks like, and they actually managed to release a version of Spotify where the play button and stuff was outside the screen. And it took like 2 hours, of course, before customers are like, we don't like your new GUI design. Why did you remove the play button? So of course that was a huge issue. And with tools like Selenium, the way you test this is generally with something like, is the button displayed? So of course if it's outside the screen, then it's not displayed, right? However, I managed to find here in this case, is that button up there displayed? Really, is it? The tool says it is. But if you move it just a little bit more to the left, it says that it's not displayed anymore. But this case, a human might say that it's displayed or not, right? So once again, sort of a problem. So these tools, they are awesome at testing this on a system level, testing the functionality of your system. Quick inputs, outputs, making sure that things work, right? But when it comes to the acceptance level, for the acceptance testing, etc., we need to do something else. And that is there where visual GUI testing comes in. So this was just set up to what I wanted to talk about. So now I really need to speed up also. Okay, so what is visual GUI testing? It's a way of taking your manual regression test cases and transitioning them using image recognition and some type of script, scenario-based for the most part, into automated test scripts that can emulate the end user for automated system acceptance testing. And the reason why they can do this is because they're interacting on the same level of abstraction as you, the user. Clicking, finding images, etc., etc., using the operating systems, mouse commands, and keyboard commands, etc. So what is this? So here's an example of one of the tools, and basically what we have to write is a little script that basically does exactly what it says here. It searches for the images that are in the methods, clicks on them, drags and moves the mouse, etc., etc. So let me just show you a little video clip of what it might look like. We can just find the play button here. And I've done this with shaky cam just so you can see that I'm not touching anything. So if I start the script, it goes over, it clicks, and then it starts typing the letters, and I'm not touching anything, as you can see. And then it goes into the web browser, and then it's done. Okay? So what did we just see happen here? This didn't look that impressive, but think about it a little bit. We are running the Android emulator in Mac OS. We do a script that starts Google Chrome within the emulator and starts interacting with it. That's a lot of different layers of different things. You're running the emulator on top of the Mac OS, etc. I have no idea what the Mac OS operating system is even written in. Is it C++? I don't know. I have no idea what the emulator is. It's probably Java, but I don't know. And the HTML, the web browser is one language, but I do know that the web page I was clicking on in the end, that's HTML and CSS and JavaScript, right? But I don't care. All I care about is what's shown on the screen, inputs, outputs. So it's a really flexible and powerful technique that we'll skip this. So how far can we take this? What can we actually test and see when we're using this technology? So here is a little example which is a little bit fun. Have you seen this little video on the net with this little robot, a robot arm that goes over and clicks on a CAPTCHA? And it's sort of a little robot arm with a pen, and it turns over and it has one of these "I'm not a robot" on the screen, and it just goes over and clicks on it and then just drops the pen, right? Pretty fun. So I was like, okay, can we do this with the tool, right? Can we do it with Selenium? I tried that first. I couldn't get it to work. Then, okay, the image recognition, you might be able to do it, right? So instead of just telling you that it works, I actually did another little video for you guys. So here's, and this is on Windows instead of Mac OS. So here, I'm not touching the mouse, shaky cam. So it goes up, inputs a website, and then the website loads, wait for it to load, scroll down, and then click here in your name. So it activates the CAPTCHA, it goes there, it clicks on the CAPTCHA, and voila, test results, right? So it manages to do it. So it's pretty fun. What you noticed here on the other hand was that, did I actually solve the CAPTCHA? I clicked on it, but then it was the next step of it, select the different, yeah? So I could do that, but the problem is that after this little video with the robot I just mentioned, this particular CAPTCHA was changed all over the world. That's the one that you can get in, what's it called, WordPress, right? And they changed it so this option to select some images or something like that afterwards, it was no longer optional, it was required, and humans can deal with it. The image recognition can also deal with it, given that it has the right images, right? But when I was testing this, something popped up that I was like, okay, sure, they will sort of believe me that we can solve it, but not really. And then I was like, okay, please solve this for me. It says, find the stop sign, click on all the images here that has the stop sign in it. I was like, yeah, that's unfair. So I couldn't really solve that, and neither could the tool. So yeah. But anywho, if you had images, you would be able to also solve the CAPTCHA, because, as I said, the only thing we care about is what is shown on the screen. If it's there, we can find it. And this CAPTCHA, I know it's a little bit, yeah, anyway. So, it was mentioned tools. There are different tools for this technique as well, visual UI testing with image recognition. One tool here, which I showed you now, is called Automate. That's a freeware tool. There's also open source alternatives like this Securely tool. They have some benefits and drawbacks, different cost models, etc., but they are for this particular purpose of using image recognition and scripting in order to do automated testing. So, what can we test with this technology? And I'm wrapping up. First of all, of course, we can take our manual regression test scenarios for system testing and also acceptance testing, given that we have a proper scenario as of how are our users really using the system, right? What inputs are they giving, what timing, etc., etc., and we could transform this into some type of regression test. Some of these tools, they even have recording functionality such that you could just put your customer clicking around and it records the scripts in the background and then you can replay, for instance. So, regression testing. Then we have smoke testing, of course. If you wanted to do something simpler, just making sure that things are up and running, just check some giving some inputs and outputs, etc. from the application. And then we also have the possibilities of doing long-term testing. This is something that has worked really well in, for instance, Saab, which I've worked with. They created a script that randomly clicked around for things. And the reason they did this was to find a memory leak that they had in their system that had existed in the system for 10 years, but they have not been able to replicate the failure condition. And they got these reports then from airports every 3 to 7 months that this whole system crashed. And they were like, oh, but we can't put the guy on sitting there and click for 3 months, right? So instead, you just restart the system then and again, right? And then when I popped up, and now let's try to do a random test, so somebody just clicks around. And they managed to replicate the defect in, 24 hours, and solve the whole thing in 7 days. So it was really powerful. And if you want to know the details, there is a paper about it, and I can also tell you how they did it. It's a pretty neat way of using this technology. And they had to use it because they needed to test it in the runtime environment also, right? So emulate the user. And then, like a warning, I've been talking about it can, be used to do automated system testing, acceptance testing, and so on. But it's a complement to your manual testing, right? It's not a replacement. So it allows you to release resources from the manual testing such that these people, these testers can work with exploratory testing stuff instead. So yeah, this is EFCs. Why should you test it in prompt? Well, one problem is that the complexity of this goes up as the test suites grow, etc., like for any technique. And there, of course, there are best practices. And this is something that we will talk about in the prompt course. So often, some problems are that you often create too many tests too quickly, you don't consider your test architectures, and you transition tests in an unfavorable way, so you get into problems quickly. But our plan then in the prompt course is to give you some ideas and thoughts and actual empirical evidence on how you create proper test design, test suite design, and also design your environment, right? And this would then allow you to mitigate costs. Okay? So, what was the difference? That was the sort of, I started off with a question and then what was the difference between the different layers and so on for verification, validation, the pictorial UI versus everything else. And what I came basically with no more sugarcoating, you need some type of UI-based testing in order to reach continuous deployment, etc., right? Because you will need to automate the validation of things, and in a GUI-based system, you need to operate on the actual graphical user interface. So, do you automate? And then the answer was, I do. First time I did this at another workshop, I was like, yeah, no one will answer. And then I went, oh, I do! Whoa, what happened? So, thank you so much. We can maybe save questions to after the thing, because now I'm gonna go then to Eva to talk, and here are some references. Pause the video, and then Eva.